So, good morning. Welcome to Ars Electronica Home Delivery. Welcome to Ars Electronica Center. My name is Hideaki Ogawa from Ars Electronica Futurelab. Today, I would like to take you to a special guided tour with Mr. Andreas Bauer,
Hello.
who is a managing director of Ars Electronica Center. Today's focus, and this is a special public lecture series of artistic journalism in collaboration with Keio University SFC Japan. We are very happy, and we would like to thank Keio University for giving us this really wonderful collaboration together. As I said, artistic journalism. So what do you think? What's artistic journalism? In a way, it's a little bit, contradictional terms because art and journalism, Art is quite subjective, artistic expression, and journalism is a very, tried to convey the truth and without any bias. So, but looking at the current situation of our society, climate crisis, artificial intelligence, new technologies, there are many concerns and issues, don't you think?
Definitely.
So this case, artists are addressing social questions in an artistic way, as a form of art pieces. This case, I think it's not just conveying such phenomenon and also the situation of a society, not like a newspaper or mass media's traditional ways, but in this way, So I would like to say artistic journalism is a quite unique approach to create a special moment and a place to meet, to create a new dialogues. So then today we are focusing on the special agenda topic about understanding AI. So before going to the detail, before passing this to Andy, today's structure of this public lecture is basically consisted of two sessions. This first session is for tour, for 40 minutes in total, and after that tour, a 10 minutes break. Then so we'll enter to the talk session, so meaning 2 sessions. And during your participation as a live, so you can post your comments, or if you have any questions, if you log in on the YouTube account, you can post your messages. So please give us your comments if you have anything. So then once again, welcome, Andy.
Thank you. It's a great honor, great pleasure to be here, and hello also to all you out there.
By the way, AI.
AI.
Here is a special exhibition AI. So why AI?
Why AI? Because AI is such a huge topic at the moment. The term artificial intelligence is not something new. I mean, it goes back to conferences in the 50s. To be honest, it's a little bit misleading, and we will come to that in a second, why, at least in my opinion, artificial intelligence is not the best term for the systems that we are using today. But it sounds nice, and it helped them to generate a lot of money in the beginning. So AI is a major part of our exhibition here in the Ars Electronica Center. We are standing here in the middle of an exhibition that we call Understanding Artificial Intelligence. And why AI? Because this is really a game changer in terms of using technology. Artificial intelligence is, or machine learning, as we will learn in a second, is a technology that we all use on a daily basis, but we're often not aware. So we are a little bit scared. There's a little bit of fear attached to this technology in a certain sense. And of course, there are ways that can lead us into wrong directions. There are thinking of surveillance and those kind of things. But of course, there are a lot of positive aspects to artificial intelligence because it helps you get the best navigation route. It helps you find pictures on the internet, and it helps you to talk with your natural language with a computer system. That's all based on and used with artificial intelligence, and without that it wouldn't matter. So it's a technology that is all around us all the time, but we need to be aware, and that's what we try to achieve in the next couple of minutes, to give you a basic understanding of how it works and why particularly biases are a topic that we need to touch on.
Super. Then let's start.
Let's start.
Yeah.
So the first part, actually, I would like to explain you a little bit how an artificial intelligence system works, or how such a neural network works. And as I mentioned in the beginning, AI is not, in my opinion, is not a correct term, because AI triggers in our mind something that we see from science fiction movies. Think of computer systems that we have on Star Trek and Star Wars, autonomous systems that are as intelligent as we humans are. Technology is by far not there, leaving alone if it ever reach or would ever reach that point which is known as singularity on technical terms. Systems that we use nowadays are something called a weak artificial intelligence compared to this strong artificial intelligence. So that's the things that you probably have in your mind is a strong intelligence. And within this weak artificial intelligence, we're talking about a system called machine learning. And machine learning means that we need a huge data set, millions and millions of pictures, of video files, of text files, depending on what kind of system we would try to create. Train a neural network in learning this thing, and training means you need to teach this system. So for example, we're standing here at a neural network training center where you can see a little bit how such a system is thinking, so trying to have a small insight into the brain of such a system, means that in order that the system recognizes this thing here as an elephant, I need to tell him that this is an elephant. I have to show him 10, 100, thousands of images of different elephants from different angles, from all kinds of views, and always tell this image is attached to the term elephant. And having a zebra as the next thing, do the same procedure again and again. You probably recognize sometimes if you go on the internet, you will come over such terms saying, are you a human? And then you have several images and you have to select, let's say, the traffic lights or the stop signs or something like that. What you're doing in reality is you train an artificial intelligence in the background. You tell this system that there is a stop sign, there is an elephant in this image, keeping it along. So keep in mind, data is one thing very, very important, because when you come to bias, the selection of this data is crucial. Coming back to our installation here is, what we have here is we have a camera and we have a little stage. And in this stage, I can zoom in, or not I zoom in, but this, the computer system is recognizing these images and is using different layers and different filters to come to a certain pattern. And then he is combining or is comparing this pattern to patterns that he's seen before and that he learned before. And then it comes up, and that's the important point, it comes up, we see it on the right hand here, he comes up with a certain probability that the object that I placed here is, in his case, an African elephant. So you see the green bar going up. The higher the bar, the higher the probability. Yeah? I'll turn it around a little bit. So just by turning it a little bit, we see it's, for him, it's not an African elephant anymore. It seems to be a Triceratops, a dinosaur. And see, it does work fairly well. This is a system being trained with 1,000 different objects. The zebra, for him, is something very big. Now we were talking about, in the beginning, why we think artificial intelligence is such a game changer and why it is up here since the last couple of years. Because as I mentioned, the topic arose in the 50s, in the 60s. And from a mathematical point of view, most of the algorithms, most of the theoretical concepts were developed at that time. What changed now is that we have a huge amount of data available, and on the other hand, we have the computer power to process this data. That's the big change. Where does the data come from? We post thousands of images every day on Facebook, WhatsApp, Google, all the platforms that you're using. That's the data piled up that enables the systems to have this huge amount of data available that is necessary to training. And of course, computer power grew radically over the last couple of years. Think of gaming industry and those graphic cards. So they made it possible to process the images. Now, one crucial point here is we can still use it on a daily based devices like smartphones, because a clever approach is that as soon as these models are calculated, the computer power is not necessary anymore. The data is not necessary. So that makes it possible to run artificial intelligence on small devices like our cell phones and everyday devices. So that's why we can easily use them on a daily basis. But as we're talking about, and we're talking about biases, one part is very, very crucial, and that's what kind of data we are selecting and how we are processing this kind of data. And we will come to that within the next installation. And I think I'll take you a little bit further, if that's okay with you.
Yeah, let's go to the next place. Yeah. By the way, this installation was developed by Ars Electronica Futurelab.
Definitely.
And as you realize, normally, this kind of content, maybe you read on the internet magazine or whatsoever. But here, you can physically understand the systems. So this is also part of artistic process. Yes. Our artists within the laboratory tried to visualize and create the experience for the public.
That's a crucial point that you mentioned, because usually there's a big fear with artificial intelligence, because you give an input to the system and you get a result, and it's astonishing how precise these results are. But the system itself seems to be, or becomes much more of a black box. People cannot look inside, and this is very much the same like our brain works. I mean, we're talking about neural networks, and our brain is the best neural network that we have so far. In a classical computer program, usually you would have an algorithm that somebody can follow the thoughts of the programmer. In an AI system, this becomes this neural network, this black box, where you cannot say, okay, this is the part that is responsible for understanding that this is a lemon and this is an orange, something like that. On a classical computer algorithm, you could read this code. In an AI system, you cannot read this code anymore. Yeah. We keep a little bit on a technical level. We have here a very nice example of how different backgrounds change in the perception of an artificial intelligence. This is a system called Moral Machine, and it's done a study by our colleagues from the MIT in Boston, and it's about judging different situations in traffic when it comes to autonomous cars, because autonomous cars obviously is one of the big markets for artificial intelligence, and we need systems like pattern recognition for devices like that. I mean, the car has to understand that this is a stop sign and what it has to do. Now, what you have to do here, you run through certain different positions, certain different situations that an autonomous car is approaching a group of people, animals, all kind of other things, and you have to select what the car should do. And the important part here is that there will always somebody die. Yeah? So there is no way of avoiding the situation of somebody being dying. So here, if you look at that example, so we see the car approaching, so we can select either this group of people are dying, or we divert the car and we say this group of people is dying. Now, if you look a little bit closer, in that case, you actually see that these people are not an homogeneous group. Yeah, you see older people, you see young people, you see male, you see female. These are things that are very, very important. So let's move on to the next example. They will come up always randomized examples. Again, you see different people. You see male and female, but have a closer look. You have to be very careful here. See, okay, this is from a social status. You see, there seems to be like homeless people on one hand, and they are not. Oops. Too quick, I was punching it. They were not following the traffic rules. They were crossing the pedestrian walk while it was red. So there's also a social implication in this kind of thing. So I'll just click through a couple of examples. So again, we have here the younger and the male versus female. You have seen also like social ranking. You see here people with a, seems like a doctor's case with a red cross on it, so it seems like this seems to be like a socially higher person, so maybe we should spare here, or we should spare the people in the car. So let's say, okay, we rank the ones with the social status high. Young kids, killing the small little girls or the boys, or we kill the, I don't know, kindergarten charge, whoever. So try that for yourself at home. This is accessible on the internet. Just Google for moral machine and you will find this kind of thing. In the end, I'll just randomize clicks through the rest so we come to the end. You will get a result, and that's very interesting because I was pointing out already some of the more specific details. So we get who did we save most? Actually, we saved the homeless people most, while we killed the business ladies in the thing. And you will see, you will get a charge in kind of others versus how did we charge thing. And matters a lot. Things like upholding the law. Yeah, did we obey the rules or did we follow the rules? Yeah, gender preferences. Humans versus pets, young versus old. Now the interesting results in this, and there's a lot of research being done in that topic here as well, is how does that play over a cultural area? Because we would say, okay, driving an autonomous car is something that should do everywhere in the world the same. I mean, traffic rules are basically the same all around the world. On a red light, you stop. But the interesting results that they found here is that things like who is going to die, these different values have a very much cultural background. And it's very interesting to see that things are not spread out evenly all across the world. Yeah? We see in different areas people judge different values differently. And we talked about understanding about this big amount of data sets. When we come to about bias and thinking that a machine is always something fair, we have to take things like cultural background into the consideration.
Absolutely, yeah.
One of the key results, I'll just slide down a little bit here, is, for example, here they found that there are differences and preferences between people from Western areas, Eastern or Southern areas. So think, for example, on where's sparing young versus sparing older people. Yeah, so you see definitely in areas Southern preferences much higher on young, also a little bit higher in Western compared to Eastern areas where young people are considered less valuable. I mean, this is a tricky term, but you see, versus older people have a higher status in terms, and that's why they should be saved on higher. So when you program or when you think about artificial intelligence, it's not so simple as you first think. You really have to be very, very careful about the data set, about the things that you pick out. Otherwise, you start to run into troubles by using these kind of systems. And when we think of who are the providers of systems like that, we think very much about Western. We think about companies like Google, Facebook, Microsoft.
Data set is quite
and the data set that they are using is thing. And there's a lot of examples. And artificial intelligence, on one hand, kind of gives us the feeling that the computer is neutral to not doing. But in reality, we found out it's not. One big example is in the US, there was a test on helping judges to make fairer judgments. Keeping along racial background, age, social backgrounds, you know, thing. So the computer system made a proposal of a judgment, and by analyzing this judgment, they found out that they had the same biases attached to the human judges, so to speak. And it's obvious, it's clear. The computer was trained.
Who was a trainer?
It was who was the trainer? The training were humans. So the computer is merely reflecting, is merely reproducing the same patterns that we humans are producing. So that's why you have to be very, very aware.
I think quickly another example.
Another example. We were already talking on image recognition. This is one big part. Connected to artificial intelligence. This is one of the things, like think of using your smartphone. Always the images are recognized. And two people, Joy Budlawani and Timit Gebru, made a research on how good, or she actually found out that she's a black woman, and she found out that actually the face recognition system on her face is working very, very weak. And she tried to find out why that is. And she created something called gender shades. So she was using, let's go back. Yeah, she was using, as I said, these major AI networks from IBM Watson, Face++, which holds a huge Asian data set, as well as from Microsoft. And she was comparing how good these systems are in reflecting and in judging different people. And she found out that, let's move on and see. You see the results here. The lighter the skin tones are, the better the system is in detecting if this is a male or if this is a female. The darker, and within the male group, actually also again, on the other hand, darker female was the group that was always recognized or had the lowest recognition percentages. Again, we come back to think then where she was looking into where does it actually come from. Just move on a little bit. You see that in this result here. She saw that the result is obviously in using and having a look into the data sets. And you have to be aware that different data sets generate and reproduce the same biases again. And then she created her own data set. And she took, what she did is she took people from more than 1,300 people from 3 European parliaments and 3 African parliaments, particularly with reflecting and having a lot of female leaders inside these parliaments, in order to create the gender shades, a data set that is much better in recognizing the differences in different skin tones and different skin colors. A very important aspect, keeping in mind what kind of data you're using and reflect on where this data actually comes from. And when we're talking about journalism, I mean, this is a crucial part in journalism to think of your sources. Where are your sources from and what kind of intention they have? And make sure that an artificial intelligence has kind of the same problems attached to it in presenting these resources. And pieces like Moral Machine or Gender Shades kind of nicely visualize the image, the problems attached to it, and the problems that people have to be aware in order to create better products, better journalism, better articles, and so on and so forth.
Connecting to everything. And thinking about our daily lives, now, such an applied products of AI is a part of our daily life.
It's definitely part of our daily life, yeah.
Then look at this.
This is one of my favorites here in the center at the moment. It's called Project Elias, and the project itself is this little mushroom here on top. Yeah, that's the real part, because what's underneath is actually a regular smart speaker that you maybe have in your home and use in our daily lives. Keep low, it doesn't matter if it's from Google, Siri or whatever, it's the same kind of problem or the same kind of topic everywhere. I think speech recognition, and that's the big game changer in this device, is great, because speech recognition is the best way that we humans can interact with a computer, because that's what we naturally do. We are talking to each other right now. So speech recognition is cool. That's the best. Keeping all mouse, finger control, everything is, I prefer speech recognition on top of it. Now the problem is, in order for these systems to work, they have to constantly listen to us. They have to constantly monitor us. And that's what these systems are doing. There's 2 little microphones attached to it, and there's constantly listening to our stream. I don't know if I like Google, Facebook, Microsoft, whoever, to constantly listen what I'm saying in my living room, leaving alone wherever, listening to my kids, because these things are also built in toys and things like that. So you have to be there. Now, a clever group of Danish designers participated in our STARTS competition, and STARTS stands for Science, Technology and Arts. And they created what is now called as a Project Elias, and this is the winner project in 2019 already, I think it's great. what they did is they developed this kind of cover on top of it. Inside this cover, there's a little computer, just a regular Raspberry Pi or things like similar system. And you see two little speakers here. And this speaker, if you would listen closely, is generating some white noise all the time. So it keeps Alexa busy and is distracting Alexa from listening to us. But the speech recognition inside here, I can program myself. I can give him a special command that only I know and not Google, in order to kind of shut down this white noise, and I can use Alexa or Google or Siri in the purpose that is actually intended for. Because it's clever. I say, okay, what's the weather? And I can look or open the window shades or things like that. So it's very convenient, but I don't want to constantly. And coming back to buyers and the starting point means that also industry people or whoever wants to sell products like that has to be aware that people are concerned about these issues. People are aware that these things are happening in the background. So they will find a way around. And in order to sell, and that's in the end, it's a business, they want to sell things and devices like that, they have to take these problems or these things into the consideration. They have to think about it and they have to adapt to it. And in that case, actually, it worked quite well because they were the group of behind Project Elias was after they won the prize here, which is actually a prize that is funded by the European Commission. So also politicians are very much aware that this is an issue, but this is a chance also for industry to create better products, more human products. And they were soon after they won the prize, they were approached by the industry and say, hey, wait a second. You raised a point, you raised an issue that we didn't consider within our product. We have to think of that. How can you please help us to make more human products, so to speak? So again, an art piece being used and has definitely an impact in that case, consumer products. And I think this is the crucial point in talking about artistic journalism.
Absolutely.
Art being used and transferred and helps us to reflect on our environment.
Yeah, absolutely. Yes, I think quite a good time to start to discuss maybe. And there are some comments, cool. But there are quite a philosophical discussion about what's the, for instance, for the life, as you showed in Moral Machine, what's the meaning of the priority? Do we have such priority? So there are many ethic, discussions, right?
Yeah, there's definitely. I mean, particularly artificial intelligence. One of these big things is autonomous driving, because this is something where I think it would be something very convenient. I mean, I would buy such a car for sure because it's something convenient, but it comes with a lot of implication to it, and it says values. What do we consider worth living or stopping, things like, because this is something, when it comes from, I've been to a workshop with a big German car manufacturers, I think it was 1 or 2 years ago, and they on their side said, well, our cars, our autonomous cars will actually never come into that situation because they will be much safer anyway, and because they have all these big technical things, radar, LiDAR, I think they will never actually end up in a situation of killing somebody. But we all know that that's not going to happen. We know that technology is never 100% sure. Now the question is, to whom do we keep this decision? Should we keep it to then the programmers and the computer persons in these companies to decide what the car will do in what kind of situation? Or should we keep it to us as a society? Maybe in one of them, that was an idea of mine, is say, okay, at the moment I'll have to make a driving license in order to be allowed to drive a car, and inside this I'll learn the rules on one hand, but I also learn how to control the car. Now, in order to control the car, you don't need this to learn anymore because the car will drive for itself. But maybe we have to make kind of a moral learn procedure and train or create our own moral system. And this becomes like the key to unlock the car. So I have my moral index been taken to an autonomous car, and you have your own set, and everybody has your own. Maybe that's a future kind of thing that our little kids were kids about the same age. They don't need to have a driving license anymore, but they maybe have to have a moral key to unlock autonomous cars and not keep it to the industry.
In this case, Ars Electronica Center is a center to get to such kind of new social skills, including moral and ethic and dignity, or respect to others, together with new technologies. So how are you designing, in a way, such kind of discourses with the students? Do you have any kind of specific kind of experiences for that?
We have one of the key success factors of the Ars Electronica Center is that right from the beginning in 1996, when it comes to this moderation, to this discussion with the audience, we deeply believed from the start that you cannot explain technology again by using technology. We're using art pieces because artists with their works raise a lot of questions. And if I approach something and I get a question, I want to discuss this question with somebody. And that's why our info trainers are so super important, because they are the human factors. The info trainers here are a group of, in total it's about 60 people, and you will probably find like 20 of them spread out all over the building at any time. And they will approach you, they will talk with you, they will come to you. If you're a regular visitor, you have a look at that installation, for example. Somebody will approach you and say, hey, can I explain you something? Have you seen that? Do you know how it works? So you need to give you a basic understanding, just like I gave you about artificial intelligence. But then they have to take you a step further. And we try that when our visitors, and we have visitors from 3 years old to 99 plus, if they leave the building, hopefully they are more mature citizen. Because picking up the car example again, we need to take that as a society, as a decision. And that's why we can use these art pieces, why we need this discussion, why we need humans. Because in the end, this technology is not falling from sky. It's humans who are developing it. And it's to us to decide on in what direction we will continue these developments. And art is a great catalyst for triggering and for raising questions. Maybe, putting the needle at the spot where it really hurts, because that's where we have to dig in.
Absolutely, yeah. And also this is a really good example, as you mentioned, about the humanizing technologies.
Yeah.
The tech companies and such, companies are just, providing their own kind of stories and experiences to the consumers. Yeah. But this kind of ideas gives the people to stop to think about our, current situation of, our society. Then, so as you mentioned, this piece was in a way utilized for the agent to negotiate for policy make, right? Yeah. So this is, I think, very important because someone needs to, take care about this, communication because otherwise we are just using the biased, such, and bias is such super hot topic, isn't it? Especially during the COVID, pandemic time. Maybe also audience, you experience a lot of, time at home, and you are exposed to, watch out many visual-oriented contents. I think visual-oriented contents are so, basically connecting to the bias. But what I want to connect is not just this technological bias, but also cultural bias, because AI itself, all systems are very, in a way, mirroring of the humans' desires and invisibility of what we are thinking. So, what's the kind important point to also for human side, because the data set itself it is anyway biased because we humans are contributing, and we needed to understand. Okay, individually it's different. But do you think this kind of, first we need to understand we are full of bias.
Sure.
Then, so what's the way to, overcome this bias? Do you have any ideas for?
It's a very difficult question because if I could, I think biases are a way are very human.
Yeah.
I mean, it helps us because and without viruses, in terms of having drawers in a cupboard, putting people into drawers and things like that, we couldn't survive the huge amount of data that our brain is constantly being fed into it. I mean, we hear, we listen. Our brain has to sort this kind of information out all the time. And viruses are a way to help him cope with this huge amount of data. So the important thing is, doesn't matter if it's human intelligence or artificial intelligence, you have to be aware that biases exist. And that we are all exposed and that we are all biases constantly ourselves. And because I think to really overcome, I mean, if we would answer that question, we could solve a lot of conflicts all around the world immediately. Because most of conflicts are because of different misunderstanding, reception biases, etc. The problem when it comes to technology is that we think that technology is fair. You know, the computer 1 + 1 is always 2, yeah, basically. So we think that, and we, at least here in a Western culture, we deeply believe that whatever the computer solution comes up with will be correct and will be a fair and equally judged solution. And no, it's not. It's just a solution like we humans have. And when we've learned that within humans we have biases and we need these biases in order to cope with data, as well the computer is seeing. So keeping aware, I mean, this is the crucial part. Both in human and technology, you have to be aware that biases exist and that you have to take them into consideration. When next time you do a judging on something, say, okay, wait a second, how did my biases influence my decision? And the same thing with technology. How does the biases that we programmed the AI with, how did they result? And when it comes to particularly on judging things like, I mean, there are systems saying on our AI systems helping to judge on how people are getting a new loan for a house or how much credits to get. We have to take these things into consideration. On the other hand, maybe we think that, or maybe we come up to a society and say, okay, an AI system should not take these kind of decisions.
Also, that's a decision.
That would be a decision as well. Saying,
because
I mean,
now, you know, nobody discusses the areas, the domains, you know, decided by the artificial intelligence.
There was a good example 2-3 years ago here in Austria. We had a discussion with the labor service, the people, the company or the service that helps unemployed people to take. They were starting to use an algorithm to judge on how likely people are to be placed in jobs again. And of course, this AI came up with, or say, female, in particular, re-entry people re-entering after having kids, re-entered the system, and they had less chance of getting a job than really. So it immediately raised a huge discussion here in Austria if they're actually allowed to use an algorithm like that to judge on people, how likely, because it's humans, it all should be treated equal. Even so, the algorithm was merely reflecting what we know from reality anyway. It was just in trying to help these people, the clerks there, to get a better job positions for them. So the discussions are, I think, the very important thing. This kind of thing shouldn't be done hidden and left to the big companies or that we were talking before.
This Ars Electronica Center's example is a good example to open such dialogue to the public through artistic, expressions, right? In a way, artistic journalism allow us to, discuss. But also, what I thought was, again, AI itself is a good, in a way, mirror of ourselves. Through this, progress of artificial intelligence, we can see the social issues through the mirror of artificial intelligence, and also our fundamental, issue of even in education, because education itself is, of course, important, but also giving us imprinting us the bias depending on the topic, though. But my point is, what do you think in 21st century as education? Not just once, got after, we got education. I think we need way to remap of knowing, because this is again not just doing something based on what we knew, but we needed to update ourselves to go over the out of the box.
Yeah, I think that's one of the crucial to start learn and have an education system that helps us think out of this box. Because when it comes to technology, AI, these things are very good, and we see AI systems that are fantastic in recognizing images or cancer cells or stuff like that. As long as they are within a kind of fixed environment where we make sure that every kind of variables are known. But we humans live in an environment where we constantly have to deal with unknown variables, and they're changing. And we have to have an education system that helps us grow. We need to have an education system that is not feeding me on when was the fight between who or that, and simply learning facts. Of course, we need to have a certain background, we have to have a certain understanding, but the education system should merely teach us and help us cope with a constantly changing environment, keeping us open-minded on biases and things like that, because as more open, and that's what I meant, what the center is here very much about, helping people understand and help and giving them a compass, a guiding tool that they can use for themselves, making them more mature citizens. That's the big topic or the big issue.
Thank you very much, Andy.
It was a pleasure.
It's a really great opportunity. Maybe also for you guys. There are quite many comments, and I tried to pick up some key elements. But I hope you are now engaged in this really hot topic, because this is never-ending discussion. But once again, thank you very much,
It was a pleasure. Great to have you here. Thank you.
By the way, after this session, as I mentioned, we are taking 10 minutes break because I needed to set up the setting for the next round. Next will be a talk discussion with special artist and researcher Adi Nikulan, who is from Ars Electronica Futurelab. And we are talking about artistic research, about the understanding, and also artificial intelligence and bias as well, and also creative meanings. So I hope you are now activated. Then so stay tuned, and once again, Andy, thank you.
You're welcome.
Then so 10 minutes later, see you soon. Ciao. You could count. Hi everyone, welcome back to the Ars Electronica Center Artistic Journalism. I'm still in the Ars Electronica Center's main gallery, -3, and the second session will be focusing on the more presentation together with Ali Nicolan, who is a key researcher of Ars Electronica Futurelab. And our main focus is creative collaboration with AI and bias. What do you think? It's quite a challenging topic, isn't it? In the previous session, our main focus was, how the machine learning worked, and also, how, the data set is created, and what's going to be the issue in society about the bias. But in the future, when you are collaborating with artificial intelligence, what's going to be the potential? What's going to be the issues? What's going to be the creative result? Then, Ali, please, and thank you very much for joining to this.
Thank you. Hi, everybody. So let me just share my screen with you. So the talk is about AI and creativity and creative intelligence, how we call it. And it is about, obviously, about creative applications of AI and how we can use AI for creative tasks. So maybe the first question is, can we really expect creativity from a machine? Because creativity is a very human ability, right? So creative ideas come in us, in our mind suddenly, and we can't really explain where they come from. And we can, of course, share these ideas, communicate these ideas with others. But at the end of the day, these ideas are kind of personal phenomenon, because so they are created, they exist in our mind without, in isolation, without outside effects. And I would like first to begin maybe with a very, very short introduction about myself and my work at Ars Electronica Futurelab. So as it was mentioned, my name is Ali Nicolan, and I'm a key researcher and artist at Ars Electronica Futurelab. And my key research topic is creative intelligence. But I have my, as I have my background also in classical music, I have my background in computer science, intelligent information systems, and classical music. So my focus, my research focus is obviously, naturally, more on musical applications. So there are a lot of questions about AI and creativity, because, as I said, creativity is very human, and maybe it's one of the last human phenomenon that machines cannot do, actually, or we assume that machines cannot do. And I would like to discuss this with you during this session. Can we really talk about creativity if machines create something, and what are the problems? How can we define creativity at all? Maybe this is also a problem. Do we exactly know what creativity is? I'm talking about human creativity, not even AI creativity. And to discuss this, I will show you some demos and examples of works have been done in that area, just to see the limitations and issues we have with the current state of AI. And of course, because the main topic of this presentation or this session, this lecture, is about bias in AI. So we will also discuss the biases in the field of AI creativity and the effect of them. So let's begin with a very short technical background to know how AI is really generate data. So first of all, the question is, why should it be interesting for research to generate data with AI? So the main assumption behind generating data with AI is that if you have a system that is able to generate data from a domain, for example, if you have a system that is able to generate text or images or music, so your system must have learned some kind of essential understanding of the data, because otherwise it wouldn't be possible. Imagine you have a machine, it can generate text. So we would assume the machine must have learned something about the language, first of all, about the grammar of the language, and also about our world, because language is reflecting actually our world, our real world, because we have all the dependencies of the objects, of the qualities in the world that we reflect them in the language. So if the AI is able to generate language, it has to learn also something about our world. And so the motivation behind AI creativity is we train the AI with large amount of data, and the AI is forced to learn dependencies and relationships in the data. And at the end of the day, what the AI has learned can serve as a new source of inspiration of human creativity. And for training, we always have a task. And usually in the generative AI, this task is just to reproduce the data, to reproduce the input data. It is very similar to the imitation task. Remember Alan Turing? So of course, in his case, it is more about behavior, but also here we have the imitation task because we trained the AI in a way that it is able to generate exactly the input as output. So you may ask, what is the sense? What is the use of it if the AI just has to reproduce or to copy the input as an output? The answer is the AI has a very certain structure, so it is not allowed to copy the input to the output. So it has to learn statistical patterns of the data. It's the only way the AI can reproduce the data, by learning the statistical patterns of the data. And by learning that statistical patterns, the AI, so it's the idea, learns essential understanding of the data. So imagine we have an AI system and it is able to generate human faces. We as humans know that human faces can vary in many different aspects. We can have different hair colors, eye colors. We can be wearing glasses. We can be, the size of our faces could be different. But we also know that there are some kind of constraint. For example, the position of the eyes is fixed. We have two eyes and only one nose and one mouth. All these things are aspects that the AI has to learn. So the AI has to learn at some point, I can be creative. I can have different combinations of eye colors with hair colors, or with the size of the nose and of the mouth. But I can't be creative, for example, if we are talking about the positions of the mouth or of the position of the eyes. So this is the idea. So to learn where it can be creative, where there are variations, and where it can't be creative. And all these things could be learned by learning the statistical patterns of the data. So what about the creativity itself? If we talk about we can be creative and generate something new just by having some variations. Is it enough or not? So there are many different definitions of creativity. One of them that is commonly used comes from Margaret Baden. And she actually defines creativity as the ability to come up with ideas or artifacts that are new, surprising, and valuable. So we have three qualities here. And I would say all of them are really, really challenging for AI systems to estimate. The newness maybe is the simplest one, because we can, if AI generates something, we can just check our training set and see if the output exists in the input, in the training set. And if not, we could say AI was able to generate something new. It doesn't mean that the data doesn't exist somewhere else or is known to everybody else, but if it is not in the data set, from the perspective of AI, we can say it is new. But surprising is even much more difficult to estimate, because surprising can only be estimated by humans in a very subjective way. Something that is surprising to me maybe is not surprising to you. And this is very difficult to estimate, and value is even much difficult to estimate. We all know about creative ideas, artworks, scientific theories even, that have been highly underestimated at the time of creation, and later they became famous and important. And this is a big problem actually in AI research, in AI creativity research to be more precise, because in research we always need ways to compare different approaches and different technologies with each other. And the question is, how can we know which model is better than the other model if we don't have objective ways of evaluation? How can we evaluate newness, surprising, and value of an output of AI in order to compare that AI with other approaches in AI? And now I'm coming to the first example. This is actually an installation at Ars Electronica Center, which is called What the Ghost Dreams Of. It is created by an international team, including John Bromley, Hideaki Ogawa, and it uses a technology called StyleGAN in background to generate new human faces. When you enter Ars Electronica exhibition, Understanding AI, where the first part of the video was, you will see a big eye symbolizing the input of the AI. And that takes a picture from your face and it transforms your face into new faces that are generated on the fly and don't exist in the real world. I think StyleGAN and generally this application is a very good example of how AI creativity works because it visualizes very good the concept of transformation. So when we train an AI system, the result of the training is actually nothing else as a set of weights and biases, so numbers. And these numbers, it is everything that the AI has learned during the training. And these numbers don't change anymore after the training. And we can imagine these numbers actually as a space. We have multidimensional space, maybe 1,000, 2,000 dimensions. So of course, it's not possible to imagine it physically, but nonetheless, we can imagine it even in 3 dimensions. So the principle is the same. And in this space, every data point has a position. In our case, every face has a position. This is one position and this is another position. And then the AI can go from one position to another position. And by going through this path, it can generate new faces. So all these faces are correct, but they are new because they are something that were not existing in the data set. So they are generated on the fly. So we have 2 positions. This position is your face and this position is the target face, for example. It can be randomly chosen. And then the AI just try to transform your face to that face in this multidimensional space of statistical patterns that have been learned during the training. And the funny fact about this is also that this space doesn't change anymore. So this is something that during the training has been learned and is not changing anymore. And the funny fact, at least for me, is that we actually are expecting creativity from a frozen solid space, from a space that is not even changed. And so it's some kind of, I don't know, unintuitive. How can a solid frozen space be creative? And therefore, I think AI creativity is not much about creation or even creativity in sense of human creativity. It is more about exploration, because this space, this is what the AI has learned from our world, in this case, from human faces, and we can explore the possibilities. So it needs human to change to choose a sample from this space and to further develop this. But this space is very good, very useful for exploration. I will go back to this in more details later in other examples too. So the next example is about generating text in the sense of creativity. You might have heard about famous text generation models like GPT-2, GPT-3, BERT, and also translation systems have a very similar structure, have a very similar architecture. So it's very similar how the training in this case also work. The training is actually to reproduce the data like in the images. So I have to say that in the images in the example before, it was a bit more complicated because we have this generative adversarial neural network. So we had two neural networks But at the end of the day, it is about generating similar data as the data in the training set. So in the GAN case, we are not going to generate exactly the same data, but similar data. But here, actually, we are going to generate exactly the same data during the training. So it means what the AI had to learn during the training is to predict only the next word, given all the previous words in the document. And it means, what is the next word? The next word can only be a word in a set. This set is our dictionary, and the AI has, so to speak, a classification task. So the classification task is very similar to to classify an object in the image. Of course, in this case, we are not classifying something that is existing in the context, but we are classifying the next likely word in a sentence. Let me give you an example. Assume we have a sentence that begins with the word today. What can be the next word? So actually, because we are not aware of any context here, and we don't know what we are going to say or what the AI is going to say, we have many possibilities here. It can be today, I, today, you, today, was, today. No, there are many possibilities. And in those cases, the AI just randomly choose one of them. AI randomly chooses one of the possibilities that can occur here. Okay, something is correct. So we can say today something, but now we have less possibilities, of course. Something funny, okay, this is also a possibility. We could say today something bad, for example, or something funny, something unbelievable. There are some possibilities, but not as many as we had at the beginning. Something funny happened. Okay, so this is the sentence, and we already have a context. We know that it is about today. It is about actually past, because something happened. It's not. We are not talking about the future. And then the sentence could continue in many different ways, but I would be one of the possibilities. You could also be a possibility. He, she, we have many possibilities, but if you have I, so the next word is somehow restricted to few options, because we can't say I apple or I don't know, water. So we should have a verb here. So the next verb, the next word word could be I was or I am. Okay, I was. And of course, this is something that we should have because of the grammar. And so now it's very interesting what it can continue, because I was at the place was probably at a restaurant. Okay, so it means you see the AI is able to generate correct text by just using the next correct word, and as the sentences becoming longer and longer, the context will be more clear. And of course, from now on, because we know we are at a restaurant, from now on the words, the options will be less, because it has to be something that is related to a restaurant and to today and to me, because I am talking about myself in this sentence. So my point is, you see, AI is able to create stories, but we still can ask what is the meaning of this, because just because it is correct, it doesn't mean that that there is a higher meaning in this story, and AI doesn't even know what this restaurant is and what today is. Of course, it has learned the statistical relationships between these words together, but still the question is, what is the value of this, even if it is correct? Surprising, maybe at some point, some stories can be surprising, but what is the value if it has no meaning? So the next example is about music generation. I took this example because it is also very similar to how we generate text. And for music generation, we at Ars Electronica Futurelab have been developing a model, AI model, to generate music, and we trained it with several thousand examples. And the task here is actually very similar to the task of natural language processing models like GPTs, because what we are doing here is actually learn the AI system or to train an AI system to predict the next node given all the previous nodes. To be more precise, we are talking not about nodes, but tokens. Tokens are nodes and other elements that could be musically interesting, like duration, for example. And the idea is, instead of words like we had in the language, we just use the tokens of music. We can also represent music as a one-dimensional sequential data, like the example shows. So we can have the pitches, we can have how long we have to wait between the notes and when the pitches end, so onset, offset, and pitch information. And by doing that, we can generate music in a very similar way like language. Of course, the model has to be different because of inductive bias. So inductive bias is a kind of bias that is in the structure of the model. So this is a good bias. It's something that if we know we are going to recognize faces or images from the real world, we can build the model in a way that it is biased, but biased in a way that it is able to generalize the pictures. And for language, we have also these inductive biases, and also in music. So this is something that is in the structure of the systems. Included. And maybe this is also interesting to mention because it is related to AI creativity in general. So the term, the word richer car we use for our music composition system is actually a musical form of Baroque and Renaissance. So very, very old form. And in its Italian origin, it means to search out. And composers 400 years ago used this term for pieces in which they actually were trying to find out the potential of a musical theme. So it was more about exploration than composition, actually. Of course, the result was composition, but this is, I think it's a very similar way how we should use AI, because AI creativity is, it is more about exploration of this space, exploration of how a story could, for example, continue, and without the intention to tell a story or to create a piece of music, I think it remains meaningless unless human artists will work with this. So I will also talk about this issue in some slides later. But before I go there, I just wanted to show you this picture. This is it shows the output of Richard Carr, but it is very similar also to language models. So you see the x-axis here actually represent the musical tokens. So the sequence from left to right. So you see this is the beginning of the piece here, and here is the end of the piece. It's of course just a segment, but to simplify this. And a vertical axis shows us the all possible tokens. So it is our dictionary. And the brightness of the dots represent or is related to how likely it is that this node or this token appears there, or actually what is the probability that AI has calculated for that node. And at some places, like here, for example, we can see that there are different possibilities. So the nodes are not very bright, they are gray, because the probabilities are divided through different tokens. And in those cases, it's exactly like the restaurant or today and the next word of the sentence, where there are many possibilities. You see it, I think, very good here in this example from real world, from real research, that AI has calculated different possibilities with more or less equal probabilities, and it will just randomly choose one of the possibilities and continue based on the decision. So you see, at the end of the day, it is random, but randomly it is able to generate correct data. So the correctness and the constraint are there, but at the end of the day, it's random. So now I'm going to the biases, and so biases, as it was mentioned actually in the first part, are overrepresentations of certain qualities in the data. For example, in the case of human faces, if we have many faces wearing glasses, so of course the data set would be biased, and the AI tends to generate people with glasses. In that case, ethically, it is not a problem, but it is not reflecting the real world, because if 90% of all people wearing glasses, so this is not the actual world, so it is not correct data, and the decision of AI will depend on the data sets and not on the facts. And so we have the same problem also in creativity, because if we have, for example, many pieces from a certain composer in the data set, so the data set will be biased, and the AI will try or will be tending to generate pieces in the style of that composer. And it is not good for creativity, because for creativity, we want to go always through new ways, right? We don't want to, to take the same path again and again. And if we have the tendency in the data set because of the biases, the AI will not be very creative, because it tends to, to reproduce the same or very, very similar outputs. So in summary, we can say that AI can create correct music, text, and images in sense of constraint, but we can use these creations, or we can see these creations more as exploration than as a creation, because for creation, we always need the intention to create. We humans always need the intention. Even now, when I'm talking to you and in this lecture, the intention is to exchange ideas, thoughts, and to share something with each other. I am not choosing my next word based on randomness, and just because the next word is grammatically correct. So I am trying to share something with you, to exchange something, and therefore the intention is the most important part of creation and not the correctness. And this is the reason why we always need humans to create. But we still have many problems, because if we agree that intention is important, so the question is, how can we communicate our intention with the AI system? And how can we collaborate with the AI system? And this is a big issue, because AI systems, they are very, very complex systems. They have millions of parameters, and it is technically not possible to say what the contribution of a single parameter is for the end result. And because we don't know that, this analogy of black boxes. And because we don't know that, it is not possible to influence the AI, because or influence the AI in a human understandable way, because we can say we can change the parameter on the run during the generation. And there is no easy way to collaborate and to communicate with AI systems now. And furthermore, these AI systems are also kind of autonomous systems, because they somehow act like autonomous agents. Maybe it is related to the fact that they are not explainable, because we can't see and we can control them. But on the other hand, I think the AI system, they are able to generate something, to do something without human actions, and therefore we can call them autonomous agents, because they don't need much from our actions. But the problem is in terms of creativity and artistic works, if you want to generate something with the AI, how can you influence the AI? How can we use the AI if it is an autonomous agent? If you compare it with classical tools like Photoshop, Logic Pro for music or image processing, you know that even if you don't know what the algorithm in background is at some point, we know we have a quite good expectation of what the effect of our action will be. If you use a filter in Photoshop, you have a quite good expectation of the result. And this is something that we don't know in state-of-the-art AI system. We can't really say how the AI will react to our input. And this is a big problem because we need that to be able to collaborate and to interact with AI. And because we need that for creation that have meanings because of the lack of intention. So thank you very much. I think it was the last slide.
Very much, Ali. So can you hear me?
Yes.
Yeah, great. Yeah, so then let's discuss. And I was very inspired from what you said concerning the, exploration. Because last year I didn't hear about the word much about this exploration in your description of the project. But now, as you are also a creator who are utilizing the AI, I think your mindset might be also developed, how to explore the new expression together with AI. And also thanks for introducing my project, this GAN, style GAN, what a ghost dreams of project. Also in my experience, when I use the GAN, style GAN, as you mentioned, I didn't intend to make something, original pieces from the result. Rather, what I intended was, again, intention, was to address the such unique process to generate non-existing faces, but by utilizing our Ars Electronica Center's experience. And if you don't know this project, I can show you this project maybe in the coming lecture though. But if you come to the Ars Electronica Center, you can find my piece. And then the main point was intention, and also art can create the new meaning. So that's, I think, the point, compared to technological exploration, because artistic exploration is also creating the meaning and also context that you address today. One question concerning the, how to say, kind of serendipity moment when you are creating new music. For instance, in my case, I might take someone inspiration, but at the moment I didn't digest yet. But I aware of this idea. But after, I don't know, several months or several years later, 1 week later, suddenly when I take a shower, the idea connects in my brain, oh, something. So this is a kind of very important creative moment to me, So in your case, when you collaborate or utilize the AI system to make something new, are you just looking for and exploring the unknown areas through the system, or do you have any strategy to have such, special serendipity that our natural brain has? A little bit difficult.
It's a very good question.
Yeah.
So actually, I think we are talking about different levels of creativity here, because if you, as an artist, if you use AI, of course, your creativity level is high level, because you can also use the AI for creating very, very crazy stuff. You are not forced to use exactly the output of the system for your work. You can, for example, take the output and mix it with your input, or even you can take the output and invert it. You can actually just create a piece of music that doesn't use any of the output of any of the notes from the AI. So I just want to say, my point is, you have, as an artist, you have to create a concept, and this concept is is a high-level concept. So we are not at the level of notes and musical tokens, and it's more about the concept, the overall concept of the artistic work. But while you are working with the AI itself, so it is more, you are at the note levels, you are at the musical level. So it means that you can explore the musical universe, so to speak, in a way that you can give the AI a melody, a musical structure, theme, and the AI gives you for example, five different possibilities how this melody could continue, or this piece could continue. And each alternative could, for example, be, I don't know, 1 minute or 1.5 minutes. And then you can choose one of them. You remember the first alternative is very, very important because it decides about the character of the piece. And then you can continue the process. You can tell AI, okay, I have chosen this one, and now continue again and give me 5 new alternatives, each 1.5 minutes, for example, how the piece can now continue. So this is the way how I compose with AI. So I ask AI to give me different alternatives for next segment, 1.5 minutes, for example, and then I choose one of them and then I continue. And then step by step, at the end of the day, I have maybe, I don't know, 10 minutes music. And it is generated by AI, but also in collaboration with me, because I was exploring the possibilities that AI gave me, and I have been choosing or selecting the possibilities. So this is, yeah.
Connecting to today's topic about the bias, also this is a very, very interesting topic. For instance, also to me, as an artist, as a person, I realized, oh, this is my bias, and also I know this idea because I needed to be out of the box, So to be out of the box, how to overcome the bias is one of the point. But in the collaboration with AI, sometimes the nice bias is very effective to find a new, completely different way, or of course, depending on the amount of the data set, if the data is more and more, incredible amount, the bias is going to be kind of flat or, a little bit, reduced, I suppose. But how does it work? How to, two questions maybe. One is how to reduce the bias in the current AI system, especially for creation. That's one question. And the second question is how to utilize a bias, in effective ways for the creation.
Yeah, there are very good questions. So I think the first question is, we don't have any answer for that, because it's the same problem we have also in critical AI. So in the creative AI, we have also ethical problems, of course, in many cases with biases. But in case of music, for example, still it's not very critical, because at the end of the day, the worst thing that can happen to you is that the AI is not creative, because it is, because it's biased, because it's tend to take the same paths again and again, and it's not willing to try new ways. But on the other hand, we can also use bias artistically for good, to be more creative. And first of all, maybe I would like to mention something, that there is a bias in us humans. We shouldn't forget that one too, because for example, in the case of music, if you think about the piano, we as human composers and piano players, we have 2 hands and 10 fingers. And we are very, very restricted, because it is not possible to have the same note in the middle and at the high area of the piano, and at the same time the very low area of the piano, because it's just physically not possible. But I actually noticed that the AI doesn't have this bias, and I was really stunned. I was stunned to see it is generating music that I, as human composer, would never generate. Because if I try something at the piano, I always am restricted to these biases, and because of my hands, because otherwise, of course, it's easier to play, and the other thing is not even possible to play. You only can imagine how it would sound, but you can't play it. And these biases is something that we humans have, but AI doesn't. And this is a good thing. But AI, of course, has other biases, or could have other biases. For example, we don't have in the data, in the training set, we don't have pieces of all possible composers. We are always restricted to some of them that are more famous, or from them we have the pieces digitalized. And so this is a bias, of course. And this is also about you at some point you have to decide, okay, I'm not going, for example, to include jazz music in the data set because I don't have enough pieces. And if I include it and the rest is classical music, so I will have a very tiny portion jazz music and many classical music. So sometimes it's good because you can then have a transformation between them, interpolation maybe, to generate something new. But on the other hand, it can also be bad, because if your goal is to generate jazz music and 80% of your data sets consist of classical music, of course it's a bad idea. It won't work. But to answer your second question, I think on the other hand, biases could also be a very good way to communicate with AI systems, because artistically. Because we have been talking in this presentation about how difficult it is to collaborate and to communicate with AI, because there is no way, no human understandable way to deal with AI, to collaborate, and in a satisfactory way. But biases could actually be a good way to do that. For example, if you want the AI to compose in a certain way, you have a style in your mind. It is your personal style, maybe, or it's from somebody else, but you want to overpresent. You want to create pieces that actually tend to be similar to this particular style. So you can, of course, add more and more data from that style into your AI system, and then the result of the AI will be tending to go to that direction. And by doing that, you can actually combine many different aspects. You can combine many different qualities just by using some kind of biases here. So these biases are biases that are intentional biases. So we intend to have these biases. And so therefore, I think as a summary, we can say biases are not a bad thing, just from the nature, but the question is, are we aware of them? Where are we using them? And so the awareness is very important. So to know that AI systems tend to have these biases, and we should have systems that are that decide based on facts and not on the combination of the training set.
Very interesting, because today, in the morning first session, we discussed about the really difficult situation about the bias, especially for social systems. And it was clear, for social systems, the bias is a very big, issues, because, the judgment decision will be reflected from the data set and also biased by the creators. But in the artistic, production and for the creativity, bias is not always bad, but it's quite similar to also our, humans' daily behaviors, because we try to be understanding someone, but we realize everyone has each subjective, perspective. And what you said is through the AI's bias, we might be able to understanding misunderstanding, of the, such machines. Then that can be a potential of inspirations, right? So this case, of course, for audience today, bias in AI is so critical topics. But for finding and exploring the creativity, how to set the meaning of bias for understanding ourselves, you know, for both critical approach, but also creative approach. I think super big topic, to be honest. And I think this is not, really confirmed domains at all. This is, I would say, quite a never-ending journey to look for. I think it's time. Always, as you know, every year we have this special live performance to make our compass together, where to go, And but once again, thank you very much, Ali, for participating in this lecture. And I would like to continue to discuss this, bias also next year, and also new findings about AI-human AI collaboration in 2022, 2023, maybe 2030 or 2050, because
at some point we will have the answers, I think.
But for all participants today, thank you for watching and participating in this special program. We have 2 more public lectures of artistic journalism, and please join. And also, you can start to think based on this creative exploration and inspirations through the guided tour of Ars Electronica Center. Then, so see you next time. Bye-bye.
Bye-bye.